Welcome back, Year 12s, to another video in this series on circular functions. Today we'll be learning to sketch sine and cosine graphs. Previously we did this with dilations and reflections, and today we're going to add the last layer on, which is translations. This pops up every now and then in exam 1, so you are expected to be able to solve equations and sketch graphs without a calculator and without notes. So we'll need to know our exact values, and we'll need to know the shape of sine and cosine by heart by the end of the year. So I've just got 4 exam questions to do today, and hopefully as you see me thinking aloud through these questions, you'll feel confident to try these yourself soon. So let's get underway. So this is a pretty old question. This is 2004, probably before some of you were born. And the graph that we're given is 3 times sine of 2 times t minus pi on 4. Okay, so if you are sketching a trigonometric graph, it's very helpful to identify the amplitude and the period. So in this case, the amplitude is 3. It's the magnitude of the number multiplying the sine or the cosine term. And the coefficient of t is 2. So this is sine of 2t with a translation. So we can use our 2 pi on n formula. 2 pi on 2, which gives me pi. So I immediately know a few useful things. First, I know that the graph is going to go between -3 and 3, and I also know that the graph is going to repeat every pi units. Alright, so now I am noticing that there's a sequence of transformations that are applied to this graph. So I can think of it in sort of 2 stages. So first, I start with sine of t, and then I do my dilations, and then I do my translation, replacing t with t minus pi on 4. So what's happening here? Well, we've got a dilation of factor 3 from the t-axis. Notice I haven't said the x-axis because we are explicitly told that the variable is t, and half from the y-axis. And then here's where we have to be a little bit careful. When you look at this minus, you might think, oh, it's going to decrease the t value. But remember, f of t minus h represents a translation h units to the right. So this is actually a translation pi on 4 units to the right. And since I know that this graph, 3 sine of 2t, will pass through 0, 0, I immediately know that I'm going to have a point at pi on 4, 0. So I can think of this as my first point on the graph. And then the graph is going to have a period of pi. So if I go across pi on 2 units, I'm going to go across half of a cycle. Notice that, remember that sine of pi on 2 is 1, the maximum value of sine. And since I've dilated by a factor of a half from the y-axis, instead of going across pi on 2 from the starting point, now I've gone across by pi on 4 to get from the mean value 0 to the maximum. Okay, so I know that the graph's going to pass through pi on 2, 3. And then by symmetry, I know that the graph will also pass through pi -3. So you should see immediately from this that from 0 to pi, I have one complete cycle of the graph. It repeats. So all I need to do is draw the same thing on the left. Get your curvature right. This is quite difficult to do on a tablet, so I'll do my best. Okay, and it's good form to label your endpoints and your intercepts. So 0 minus 3 and negative pi minus 3. Okay, so very doable. The key point was to recognize the period was pi, and we had a translation of pi and 4 units in the positive direction of the t-axis. Okay? Right. That's one example down. I've got 3 left, so I'll try to keep this video short so it's not too onerous on you. Here's the next question. So this time we are asked to sketch y equals 5 times the cosine of 2 bracket x plus 3. You'll notice the structure is pretty much the same as the 2004 question, except now they've changed sine to cosine. They've even helped you in this question by asking you to start by writing down the amplitude and the period, and they've given you a mark each. So the amplitude is 5, and the period is 2 pi divided by the coefficient of x, which is 2, so period is just pi. And part A is meant to help you with part B. So immediately I'm seeing that the range of this graph is going to be negative 5 to 5. All right, I'm going to do the same thing with the transformations that I did before, except this time I'll start with y equals cosine of x, then y equals 5 cosine of 2x, and then I'll chuck in the transformation at the end, replacing x with x plus pi on 3. So what transformations have we done? We have dilated by a factor of 5 from the x-axis and half from the y-axis, followed by a translation pi on 3 units to the left. Why is it to the left? Because it's f of x plus some number rather than f of x minus some number. If there's anywhere where students will go wrong, it's usually at this point here, getting the translation in the wrong direction. So please be very careful of that. Now, in the last question, they labeled pi on 4, pi on 2, 3 pi on 4, and pi. Here, it looks like they haven't, but they actually have. They've given us pi here. Okay, so it's useful to, at this point, count how many lines there are between 0 and pi. And so if you do that very quickly, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 divisions between the origin and the end. So I'll just make a note here. One grid line is pi on 12 units in the x direction. Now, we're not used to dealing with pi on 12, but if you look at the fact that we've got a 2 here, we're very used to dealing with pi on 3 and pi on 6. And so if I halve those values, it's actually going to fit very nicely on this graph. So there are a number of ways to do this, and you're probably tempted to go and solve an equation to find the x-intercepts, but I'm going to use the translation approach. So what do I know? I know that when I start with y equals cosine of x, I have a point with coordinates 0, 1. Remembering that the cosine graph looks like this. So I'm interested in thinking about what's going to happen to this particular point, 0, 1, and then I can start drawing my cycles. So after the dilations, well, it's going to go to 0, 5. The dilation from the y-axis doesn't change the y-intercept. And then I do the translation. So it's going to be negative pi on 3, 5. And negative pi on 3 is the same as 4 pi on 12. So I need to go across 4 units and go up 5. And here's my first point. Negative pi on 3, 5. And now I'm asking the question, if the period is pi, then if I go 4 away from pi, I should get back to the same point again. Furthermore, I know that every half of a period, I transition from the maximum value to the minimum value. And there are 12 grid lines in one period. So if I go across 6 grid lines from either side, I should now get down to my minimum value. And then if I go across pi units, get the same thing. You see how I've gotten these points on the graph without really having to do any substitution. I've just done transformations. Okay? And then we also know that there's going to be an x-intercept halfway between the minimum and the maximum. So if the spacing between the minimum and the maximum is 6 grid lines, then the x-intercept, will be spaced at intervals of 3 grid lines between each maximum and minimum. See that? I've already got a really good idea of what the shape of this graph is going to look like. Okay, so final order of business. We are asked for the axes intercepts, which means I need to find the y-intercept. And it's not clear what that is, because the y-intercept occurs after the transformations have occurred. So we will need to do a substitution here. So let's go ahead and do that. When x equals 0, y equals 5 cosine of 2 pi on 3. Using the unit circle, this is in the second quadrant. This is pi minus pi on 3. And we know that cosine is negative in the second quadrant. So this is the same as negative 5 cosine of pi on 3. And by now you're starting to memorize these values. Cosine of pi on 3 is a half. So this is negative 5 on 2, or negative 2.5. And because the period is pi, I also know that the endpoints, pi and negative pi, will give me the same y value. So we have pi, negative 5 on 2, 0, negative 5 on 2, and negative pi, negative 5 on 2. Okay, and at this point, you can join the dots to create a graph. I'm going to use some symmetry to help me do this sketch. So notice that if I go across 2 on either side, I should get the same change in y, and it's actually the same on the other side as well. So if I go across 2 from the maximum, I should go down by 2.5. And with just a few more points added in, you can see that the shape of the graph is really becoming quite clear. So let's go ahead and sketch the graph. I will do my best. It's not that easy on a tablet. I would suggest that you use a dark pencil for this on exam 1. And the reason is when they mark exam 1, exam 2 in methods, they actually do it scanned on a computer. So if your pencil is too light, it may not scan properly. I think that's good enough. It'll do. It's not perfect, but that's the nature of doing this on a tablet. So I'll quickly label the intercepts. one grid line is pi on 12, so that's a negative pi on 12, and this is negative 7 pi on 12. And this is 5 pi on 12. And this is 11 pi on 12. Remember that since the period is pi, the x-intercepts will be spaced at half the period, which is pi on 2. Okay, so not too bad once you do it, but if you look at the fact that this is 3 marks, if you're working at exam pace, you need to do this in about 4.5 minutes. Since this is a harder question, maybe you give yourself 5 or 6 minutes. It's actually pretty difficult to do a question of this complexity in that time. And remember, you won't have a teacher by your side encouraging you with the right questions to ask. So you will need to become quite confident with this by the end of the year. Okay, let's quickly do a couple more examples. All right, so this is a more recent exam. You'll notice that I jumped from 2006 to 2018. And that's because in that time, there was no graph of sine or cosine, other than a really simple one with no translations. So it can come up, but it doesn't come up that often. But you don't want to be caught out simply because you didn't study it. So I've included this example because it is recent, so it's worth your attention. All right, so by now, you're getting used to the fact that cosine is between negative 1 and 1. So if I multiply it by 2, the graph will become bounded by negative 2 and positive 2. And finally, if I add 1 to everything, we see that 2 cosine of x plus 1 is bounded between negative 1 and 3. And the mean value is actually going to be at x equals 1. So we are asked to sketch one cycle of 2 cosine of x plus 1. And in this particular paper, they helped you to find the x-intercepts. So we'll quickly do that. So part A, we are asked to solve the equation cosine of x equals negative a half. And since cosine is negative in the second and third quadrant, we know that x is going to be pi minus pi on 3 and pi plus pi on 3. Since we know that cosine of pi on 3 is a half, and so that's going to give me 2 pi on 3 and 4 pi on 3 as my x-intercepts. Okay, so I know I'm going to have an x-intercept here and an x-intercept here. And I know that the graph will start at 0, 3. The period is 2 pi. So when I get to 2 pi, it's going to be the same value. By symmetry, the minimum will occur halfway between the minimums. So pi minus 3. And since the graph goes up by pi on 3 from the maximum, so if you go away by pi on 3 units along the x-axis, your y value changes by 1. I'll get the same thing happening here. So I automatically get these 2 points as well. Now feel free to check that if you like. Okay, and so by symmetry again, these 2 points are equidistant from they're equidistant from the mean. So the mean value at 1 happens halfway between pi on 3 and 2 pi on 3, as well as between 4 pi on 3 and 5 pi on 3. And now I can sketch the graph. You don't have to add in these extra points, but I like to do that because it helps me sketch the graph. Okay, so we've labeled the endpoints, we've labeled the minimum with their coordinates, so that's actually all we need. Okay, nice and easy. It actually wasn't as hard as the previous question, but this one was also worth 3 marks. So I guess the takeaway here is not all marks are created equal. This was much quicker to do than the 2006 question. All right, one last example and then we're done. So this is 2019. The domain is a little bit unusual. We haven't got a full cycle. And we are told to sketch the function g of x equals 1 minus f of x, which is defined up here. So it's 1 minus cosine of x on 2. Over the interval negative 2 pi to pi. And they've actually given you the graph here. So there are 2 approaches to this. One approach is to just sketch this graph without really considering the graph above. But I actually think here it's better to use the fact that we have this graph because we can actually use addition of ordinates. This is a technique where we have the y values of 2 graphs and we simply add them together to get the graph. Now, we have to be careful because we're not adding cosine of x onto it, we're actually subtracting it. So you should think of the mirror image, which is this. So in green, I've got just this part, negative cosine of x on 2. And then what I want to do is take that and move the whole thing up. So think about it this way. Let's start at the endpoints. So if I start at pi, if I take the negative of that, nothing has happened. And if I take 1 minus that, I just get 1. Now let's consider the y value 1. If I make that negative, I get negative 1. And then if I take 1 plus negative 1, I get 0. These 2 y values are the same. So these 2 y values will be the same. So I get another point here. And now if I make this negative, I get to positive 1. And then if I add 1, I get a point up here. So if you think about it this way, if my graph looks like this, if I make it negative, the maximum becomes a minimum and the minimum becomes a maximum. So my graph is going to look like this. This is quite difficult to draw. But there we are. And here are the coordinates. Pi 1, I should say. Negative 2 pi, negative 1. And from the graph, there are intersections. I didn't even consider the intersections, but 1 minus a half gives you half. You can clearly see that at 2 pi on 3, the graphs pass through the same y value, which is a half. Okay, so if we didn't have the graph of f, we would need to do this from first principles, where we start with the dilations, the reflections, and then apply the translation. So my suggestion would be, I would start with the point 1, 0, with the graph doing this for cosine of x. Then I apply the reflection and the dilation, which causes this to happen. First, the graph is going to flip upside down, and the graph is also going to take longer to complete a full cycle. And then you apply the translation last. So now if I plus 1, yeah, this is going to be okay. Just have to be sure. So you'll get this happening. And you'll see that this shape actually matches the graph that we have above. It's just that we are stopping at pi and negative 2 pi, so we don't get the full graph. So we'll draw what we have here. Okay. All right, so sorry that was a bit messy, it wasn't perfect, but clearly it was easier to make use of the graph that we were given. So I guess my suggestion is, if you're given something in the exam, usually it's because it's there to help you. Now that's not always true, because sometimes they give you unnecessary information, but I think with some experience, you'll be able to tell that the graph given to you helps you to solve a related question. All right, so I'm now assigning for you to try exercise 6F and 6G. This is where they have both horizontal and vertical translations, including at the same time. I would say just do your best. If you have grid paper, make use of it, and don't worry if your graphs aren't perfect. Get the main behavior at the endpoints and the period and the amplitude correct, and the rest will follow on the exam where they give you grid paper. All right, thanks everyone. We'll see you tomorrow.